Hello neighbor. I did a build today on Protoboard and I thought to take a time lapse of my activity. And so I thought I'd share that with you. The first thing I like to do is mark out the edges of the board and trim those off. It'll save space in the case. The next thing I do is use this red marker to mark my cuts. This is where we're going to cut the copper trace on the other side of the board. I'll use this blue marker to mark the links and another little blue marker, finer tip, to indicate where I want to run wire. So here I'm going to use a tiny bit of wire on a resistor to transfer my cut marks to the other side of the board. With that done, we'll put a little label on it and start drilling. Where's the drill? Okay, here we go. So I like to use a drill. You could use a pin vise, but the drill went really fast. It went a little too fast. I did put a hole in the board, so try not to do that. It didn't really hurt anything though. When I was done, I like to check my traces with the continuity meter on my digital multimeter to make sure that I got those cut, because if you leave even a little bit, it might be invisible or nearly invisible, and it'll totally wreck your circuit. So after I get all that done, we'll bring in the solid core wire and make the links that are indicated on the layout. There are a couple places where you'll need to join two pieces of wire through the hole. My wire is too thick, so I just wrapped it around and we'll solder that together on the top. Yeah, and that's the same thing electrically. Trim the whiskers off, and we'll move on. Oh, somebody focused that. Thank you. So there's the link wires. These are the ICs I'm pulling out and just getting my parts ready. The wisdom is to do your smallest components first so that they're out of the way. So that's usually the resistors and diodes first, and then capacitors and ICs and anything else that's big and stands up, do that last. I like to use poster tack as a assistant. That'll keep the little bits on the board, and I can pull it out and shape it any way I want. And then I'm using a cheap helping hands device to hold the board on my workbench. I just go value by value on my resistors. I'll get out the bag of 1K resistors and do all those, and then do all the 220K or whatever. I don't like to read the value on the resistor. I don't even bother with it. When my supplier sends me a bag of parts, it's got the human readable form on there, and I just pull off the tape and work like that. So in the original circuit, this particular section would only be one electrolytic capacitor, but electrolytic capacitors are known to fail, and in other builds I've substituted them with tantalum or mylar film or some other capacitor that doesn't fail as often. But here I found in my previous build that if you use a tantalum capacitor there, it doesn't have the correct discharge profile, and where I want a sawtooth or a triangle wave, I was getting way too much of a logarithmic curve. I didn't like it. So this is my compromise. We'll put it on the bench. In a future video, we'll put this on the bench and see if it has the right speed and waveform characteristics. These are the IC holders. There is some wisdom that you shouldn't use these in audio circuits, that you should go ahead and solder your chips directly in. I don't know how I feel about that. Personally, I'm okay with what I've heard so far. But if I run into more noise issues, I'll definitely consider soldering my chips directly to the protoboard. I like the ability to replace them. That's just me. And that was it. I didn't do a very good job showing the LDR build, so maybe I can patch that in here at the end. Thanks for watching.